Hello students, welcome to my channel. In last two videos were based on the capacitor, some derivations related to the capacitor. The first video was based on that what is capacitor, what is the concept behind storing maximum charge. Today's topic is this is a third part of capacitor, right? This is part 3, and today's topic is based on that what happens, what is the impact on charge, uh, potential, capacitance and energy, stored energy of capacitor when a dielectric is introduced, right? So impact on different parameters when dielectric is introduced. Dear student, case first. If battery is not connected, the moment when dielectric is introduced between the plates of capacitor, at that moment, case first I am considering, if battery is not connected, then what happens? Dear student, I am taking the example of parallel plate capacitor. This is a parallel plate capacitor. One is a positively charged and another is a negatively charged. The area of each plate is A and the distance between the two plates is D, right? The two plates are departed by a distance small d. Then capacitance works out to be C naught is equal to A epsilon naught upon D, that we have derived in last video. Dear student, this is an air-filled capacitor. Means between the two plates there is an air-filled capacitor. The question might be asked, the different questions might be raised. I am giving you some homework. Look here. Here is a two plates, right? This is positively charged. This is positively charged also. Now question is that, is it the capacitor? Will it work like a capacitor? Will this formula work on this capacitor? No, it is not the capacitor. The basic concept behind the capacitance is, the capacitor is consisting two plates or two spheres or two coaxial cylinders and both are oppositely charged, right? If both are same charge, both the plates are having the same charge, then it is against the concept of capacitor. The concept of capacitor, what is the concept behind storing maximum charge? Actually, I have told you all in my last video that if you increase the charge, Q is directly which parameter decides. Question is that which parameter decides that how much charge a body can be given or a capacitor can be given. That is potential. If you increase the charge, potential increases, and you have increased charge so much that the potential level of the capacitor has reached to a level or potential level of a body. Everybody in this world is a capacitor. Everybody has a bit capacity to store the charge, whether it is a conducting or non-conducting body, no matters. If what I have said, that if you increase the charge, then voltage of that body increases, and ultimately gradually you are increasing the charge on that body, and body has reached to a level of this voltage 3 into 10 to the power 6 volt. This is called the body has come to the breakdown, body has fell to the breakdown, and at that moment, if further you will give the charge to the body, the charge will leak into the air, right? So This is called that you have brought the body into the breakdown. So first you can give further charge. First you have to decrease the potential. So capacitor is what? Capacitor is a type of arrangement in which potential is decreased, just not by decreasing the charge. Yet charge is not decreased, but the potential is decreased. How? That is why the capacitor, it is a basic and necessary condition that the capacitor should have the two plates oppositely charged. Because of this positive plate, potential increases, but because of this negative plate, potential of this very plate decreases. It means you are capable of decreasing the potential, and when you decrease the potential, now further you can charge it to bring it to this level, right? Dear student, question is asked. If you are a student of IT or NEET, you must be very aware that, like, it is the two plates of capacitor are this. Then, and it has the area A, right? And this one has a area 2A. And they are small distance apart. This is positively charged and this is negatively charged. Then actually you have to take that much of area only, right? That area, what I mean to say in this case, you have to consider the area that two plates are facing to each other, or otherwise, and the other area is not going to work. Dear students, let's talk about today's topic, that if battery is not connected, right? Impact on different parameters when dielectric is introduced, right? Case first, when battery is not connected. The four important parameters we have to discuss when a dielectric between the plates of capacitor is introduced. First is, what is the impact on the capacitance? Second is, what is the impact on the charge? What is the impact on the potential? What is the impact on the electric field? And what is the impact on the potential energy? Actually, in next video, I'll talk about the energy stored in the capacitor. That I have not made video on this way topic, but next video I'm very sure it is going to be the energy stored in the capacitor. Yet it's a very simple derivation, you know, but we'll talk. Now, dear students, the impact of different parameters when dielectric is introduced. Case first, if battery is not connected. When the dielectric, I have considered the case when battery is not connected, right? If battery is not connected, then what is the impact on the capacitance? If whatever charge is given to a capacitor, it is not going to affect the capacitance of the capacitor. Capacitance is defined as its ability to store the charge. What charge you give is your matter, right? So whatever charge you give or not, right? Capacitance is not affected by the charge given to the device. So what happens if you introduce, you know, C naught is equal to A epsilon naught upon D. If dielectric is introduced between the plates of capacitor, whether it is connected with the battery or not, no matters. C will become A epsilon naught K upon D. It means C is equal to C naught into K, where C naught is the capacitance of parallel plate capacitor when it is air filled, and C is the dielectric field parallel plate capacitor. Now C is equal to C naught K, means if dielectric is introduced, the capacitance becomes K times, and K is always greater than 1. For air, you know, K is equal to 1, whereas for water, its maximum value is K is equal to 80. It means C is greater than C naught. It means by introducing the dielectric between the plates of capacitor, the capacitance increases K times, right? And because K is greater than K, K is greater than 1 for all the materials, for all the dielectrics. For air it is 1 and for water K is equal to 80. So C is always greater than C naught. Now dear student, let's talk about the second parameter. First parameter we discussed that if dielectric is introduced, the capacitance becomes K times. Second, let's talk what is the impact on the electric field if the dielectric is introduced between the plates of capacitor, no battery is connected, then what is the impact on the electric field? Actually, by introducing the dielectric between the plates of capacitor, the electric field is reduced and becomes 1 by K times. It means E becomes less than E naught. E naught is the electric field between the plates of capacitor in the absence of dielectric, and E is the electric field in the presence of dielectric. How it is? Look here. This was the positive plate and this was the negative plate. Between the two plates, a capacitor dielectric is introduced. Actually, dielectric is what? It is a combination of polar molecules, right? Now, in front of positive, it attracts the negative pole of the dipole of dielectric, and this positive one attracts the positive pole. And now look here, the applied, because of this capacitor, our applied field is E, and the induced field because of dielectric is this EI. So the two fields are opposite to each other. That is why the field by introduction of the dielectric will be reduced. And what will become? E is equal to E naught by K. Right? This was the second B. C parameter. Let's talk about the B. You know, E is equal to V upon D. In my last video, I have discussed at length that how E is related with the V. Actually, E is a vector quantity, V is a scalar quantity, and electric field E is represented as a negative gradient of potential. I have talked with you all. E is equal to minus grad V, or E is equal to minus dV upon dr. This is the way to define or to derive the electric field from the potential. You can say gradient is an operator which converts the scalar into vector. Gradient d by dr is said to be the gradient operator. Dv upon dr, you can say that the change in potential with respect to distance. So E is equal to minus grad V. Look here, V, potential is a scalar quantity and E is a vector quantity. A vector is derived from the potential, or you can say gradient is a operator which is applied on a scalar and converts it into vector. Gradient is a operator which is applied on a scalar, convert it into vector. In last video I have talked with you. Now dear student, E is equal to V upon dr, V is equal to E into D. So look here, if V is equal to E into D, if E is equal to E naught upon K, then V is equal to also V naught upon K, right? So the potential, electric field and potential reduced by 1 by K. Dear student, if battery is not connected and dielectric is introduced, then we talk that capacitance becomes K type, potential becomes, electric field becomes 1 by K, reduced, potential becomes 1 by K, and D is a what? What will be impact on the charge? Look here. What will be impact on the charge? Undoubtedly, by the introduction of dielectric, capacitance has increased, right? Capacitance has increased, so charge should increase, but charge will not increase here. Why? Because it is not connected with the battery. If battery would have been connected, then charge must would have increased, because concept is what? Potential has reduced. Now in order to get that potential level, you have to give more charge. It means charge on the capacitor increases by introducing the dielectric between the plates of capacitor. So charge in this case will remain same, yet capacity, again dear student, try to understand, if battery is not connected, right, and you have introduced the dielectric, then what I have said, that C becomes K times electric field is reduced by 1 by K. If field is reduced, then potential will be reduced because V is equal to E into D. And yet capacity has increased. If charge will be given, the charge will increase on the capacitor, but actually what is problem? That battery is not connected, so from where you will get the charge? So that is why the charge will remain the same, right? Q is equal to Q dot. And the last one that we have to discuss is what is the impact on the potential energy. Really, U is equal to, you write half CV square or half Q into V. This formula I have to derive in next video. I'll discuss with you all. Now, dear student, look here. U is equal to half CV square. So, this is U naught. So, U is equal to, in the presence of dielectric, it is actually C naught, it is V naught. You might write like this, 1 by 2, U becomes half CV square in the presence of dielectric. Now look here, half C is a Kc naught, right? Capacitance has increased in the presence of dielectric, but V has reduced by V naught by K, and so it is V naught square over K square, and so it will become half C naught V naught square over K, or that is U naught by K. So you can say that potential energy will also be reduced by K, right? It will become 1 by K. Sorry. So dear students, let's talk about altogether talk about all the parameters that we are discussing about the impact on different parameters of the capacitor in the presence of dielectric, but case is that battery is not connected, right? The case is that battery is not connected. Impact of different impact of dielectric on different parameters case 1, in absence of battery. Let's talk all together at a glance. Dear students, look here. The symbol of battery is this much. This is positive. The bigger one is a positive represented by, it is symbolic. It is not like so actually. Both the plates are parallel, right? This one is a bigger one represents the positive plate and a smaller one represents the negative plate. And this is the capacitor, right? Both are parallel. One is positively charged and the other is negatively charged. Dear students, some important thing let's talk. Because if you are studying the electricity, some basic concepts you should have. The very first thing, what is the international direction of current? The flow of positive charge, the direction of flow of positive charge represents the direction of current in the wire, and the flow of direction of negative and the current is opposite to the flow of negative charge, right? We'll talk in next video when current and electricity we will talk in next chapter. Then I'll talk at length about all these factors. Dear student, but sometimes people get confused. What is the difference between these two? This is a battery and this is a capacitor. Battery is what? Battery is a factory to produce the charge. Battery has a capacity to produce the charge. But capacitor does not have a capacity to produce the charge. It is a device to store the charge from somewhere else. You have to give the charge to it. Only then it will store. Right? Now, dear student, let's start. That we have introduced the dielectric between the plates of capacitor, but in the absence of the battery. Battery is not connected. So, the first parameter A, that is capacitance, becomes K times. Second parameter, that is V is equal to V naught by K. Right? The potential is reduced. Why? Because field is reduced. First, we should have, I would have written E is equal to E naught. First, I would have written the electric field, then it would have been more better because potential depends on the field, right? So, capacitance becomes K times, electric potential and field is reduced by 1 by K, and third is a charge, because on the capacity of capacitor, it does not matter. Charge remains same. Actually, charge comes from the battery and you have disconnected the battery. So, yet capacity, by introducing the dielectric, capacity of the capacitor increases, but it means it can store more charge, but the more charge from where will you get? You will get from the battery and you have disconnected the battery, so the charge will remain the same, right? Because yet capacity has increased, but you are not getting the charge from the source. And the last one is that U is equal to U naught upon K, right? The potential energy becomes 1 by K, means potential energy also reduced. So, the capacitance becomes K times by the presence of dielectric in the absence of battery. Charge remains same, whereas potential, electric field intensity and potential energy all are reduced by 1 by K, becomes 1 by K of its initial value. Now, dear student, what happens in presence of battery? Now it's interesting. In presence of battery, let's talk. Dear student, the important is you write C is equal to Kc naught. Now look here, whether the battery is present or not, even at the start I have said that the capacity of a capacitor does not depend on the charge anyhow, right? So, whether the battery is connected or disconnected, no matters. The capacitance in the presence of dielectric becomes K times, right? So, whether battery is connected or not, no matters, but the C becomes K times, right? Now, dear student, important is that what will be impact on the potential in the presence of dielectric if battery is connected. What I have told you, that in the absence of battery, if you have introduced the dielectric, the potential becomes V naught upon K, right? So, whatever, that is, K is actually greater than 1, so V is less than V naught. It means potential is decreased. Look here, in the absence of battery, potential is decreased. Now, as soon as you connect the battery, it will be charged. Capacitor will get more charge from the battery till the potential of the capacitor reaches to the initial level. Look here, dear student, if you have not connected the battery and if you have introduced the dielectric between the plates of capacitor, then potential is reduced, right? And this is the concept of capacitor, that how the charge on the capacitor is increased. The basic concept is that without decreasing the charge on the capacitor, first you have to decrease the potential, and if you if you succeed in decreasing the potential without decreasing the charge, then you have a chance to give more charge so that it can come to the same level of potential. So dear student, as soon as dielectric is introduced, the potential is decreased. Now you can give the more charge so that it can reach to the same initial potential level of this. It means there is no change in the potential if dielectric is introduced in the presence of dielectric, but there should be presence of battery too. If the dielectric is introduced between the parallel plates of capacitor in the presence of battery, then the potential will be same, right? Why potential will be same? Let battery is not connected between the plates of capacitor, you have introduced the dielectric, then V is equal to V naught by K. Potential is reduced. Now potential is reduced means you have a chance to give more charge to the capacitor so that it can reach to the same potential level. But as soon as you will connect your capacitor with the battery, it will get more charge and then it will reach to the same potential level, to the initial potential level. That is why what I am saying, yet you have introduced the dielectric between the plates of capacitor, but in the presence of battery, it will yet potential is reduced, but in the presence of battery, it will get the charge, it will charge again, it will get more charge so that it reaches to the same potential. And now dear student, V is equal to, V is equal to E into D, or E is equal to V upon D. If potential doesn't change, potential gets same value, initial value, then E reaches to the initial value also. So there is no change in E. And what will we change in Q? What I am saying, by the introduction of dielectric, you have been capable, you got success in decreasing its potential, and in the presence of battery, you can give more charge. It means the charge increases and charge becomes K times of its initial value, right? And what the last parameter that I have to talk with you, that is a U. U is a, you can say half C V square, or half C is a K C naught, and V is a same V naught. V is equal to V naught in this case, so is equal to K half C naught V naught square, or K U naught. So potential energy also becomes K times, right? In the absence of battery, potential energy was reduced by 1 by K, right? U is equal to U naught K. But in the presence of battery, U becomes K U naught. Dear students, I tried my best to let you understand the basic concepts involved in the capacitance. Actually, if you are a aspirant of ITJ, NEET, then you should have a thorough knowledge. You should have at least the basic concept that how the things keep changing, right? So I tried my best to let you understand all these basic things, and I tried to make you familiar with these concepts. And if you think that I have got success in my aim, then I hope, and it's my special request to you all, a request from deep and sincere of my heart, that if you think that my videos are going to be beneficial to you, then please and please like, share, subscribe, and must put the bell icon so that you might be notified about my next video. Till then, good night, Shivratri.